Welcome to today's deep dive. It's the week ending July 27, 2026, and today we're looking at the China Nuclear Build's weekly update.
Yeah,
And, I mean, the numbers we're looking at today are just, they're pretty staggering.
they really are. But before we jump into the deep end of the data, I do need to set some ground rules for you, the listener.
Right, the disclaimer.
Yeah, exactly. We are doing a strictly factual briefing today based exclusively on the latest source documents. So, this is for informational purposes only. It does not constitute investment advice. We aren't talking about stock prices or uranium spot prices or, how to position your portfolios.
Yeah, stock picks today, got it.
Right, just concrete, steel, and grid connections.
Which is, frankly, fascinating enough on its own. Because if you look at the global map of nuclear energy right now, as of mid-2026, the entire landscape has shifted. According to the China Nuclear Energy Association, China's combined nuclear capacity, so that's operating reactors, plus what's under construction, has reached approximately 125 gigawatts.
Yeah, 125 gigawatts.
Which, just to put that in context, officially puts China in first place globally, surpassing both the United States and France in total installed capacity.
Yeah.
I mean, how did we even get to that 125 number?
Well, you have to break it down to really see the scale. So the foundation is the operating fleet. Right now, they have about 60 commercial reactor units that are actually operating.
Okay.
And those 60 units are delivering roughly 62 gigawatts of capacity to the grid.
So that's what's currently keeping the lights on.
Exactly. But then you have to look at what's covered in scaffolding right now. Across 19 different sites, there are 36 reactors under active construction.
36.
At once. At once. And those 36 units represent an additional 39 gigawatts of capacity. And honestly, if that wasn't enough, there are 16 more units that have already been approved. They just, haven't broken ground yet.
That is just a tidal wave of infrastructure. And they have a formal policy driving this, right?
Yeah.
The 15th five-year plan.
Yeah, the 15th five-year plan, which was just approved back in March of this year, 2026, it covers a period up to 2030. And their formal target is to hit 110 gigawatts of operating capacity by 2030.
Just operating.
Just operating, right. And looking at the sheer pace of the construction starts and the commissioning milestones, it suggests they're incredibly well positioned to meet or even exceed that. Like in 2026 alone, they've already started construction on 2 new units, and they expect to commission 7 reactors this year.
7 in 1 year. The dates in this weekly update are just, it reads like a tech company dropping new products. It's so fast.
It really does.
Okay, let's just look at recent weeks. You've got Changjiang Unit 3 achieving its first criticality on July 10th.
Right, which is a massive milestone.
Yeah, and then just a few days before that, Taipingling Unit 2 got its first grid connection on July 4.
And that's just July.
Exactly. If you roll back to April, it's the same thing. Taipingling Unit 1 went into commercial operation on April 19, and then Sanao Unit 1 went commercial on April 29.
And while they're finishing those, they are simultaneously pouring concrete for new ones.
Right, because Taipingling Unit 4 just commenced construction on May 10, and Jinkumin Unit 2 poured its first concrete on April 7.
And we can't forget Sue Unit 1, which kicked off construction way back on January 16th. That was actually the very first nuclear project under the new 15th five-year plan.
Okay, so the sheer volume of these milestones is dizzying. How are they doing this without the entire supply chain just buckling under the pressure?
Standardization. That is the magic word here. A huge chunk of this pipeline is built on a single standardized design.
The Hualong one.
Yes, the Hualong one. It's their domestic workhorse. By standardizing the blueprint, they're not reinventing the wheel every time they pour concrete. The supply chains, the construction crews, they all know exactly what they're building.
So it's basically an assembly line for nuclear reactors.
Exactly.
But see, here's where it gets really interesting for me. If the Hualong one is this perfect, reliable workhorse, why diversify? Because the source data shows they're not just building the Hualong one.
No, they definitely aren't.
They're deploying the CAP-1000, which is their localized version of the AP-1000 at all these different sites. Haiyang, Lianjiang, Zudapu, Beilong, Lufeng.
And it goes beyond that, too.
Right, because they're also building Russian VVER 1,200 units at Zudapu. So why do that? Why fragment your supply chain if you already have a domestic model that works so well?
It's a great question. And, it comes down to a few things. First, it absorbs global best practices. You're working with different engineering cultures.
Keeping the global connections warm.
Exactly. It engages multiple international supply chains simultaneously, so you're not entirely dependent on just one domestic pipeline or one specific technology. It hedges your bets.
That makes a lot of sense. So they have these standard massive water reactors as their reliable baseline. But the update also covers some stuff that's just totally on the frontier of nuclear tech.
The advanced reactor pipeline, yes.
Yeah. Like, let's talk about JUA Unit 1, the one that started in January. The source notes it as a PWR HTGR coupling project, which means they are coupling a pressurized water reactor with a high-temperature gas-cooled reactor.
Oh.
What is the point of that?
So traditional nuclear is all about generating electricity for the grid, right?
Right.
But heavy industry needs something else. They need massive amounts of raw physical heat. Industrial steam.
Oh, interesting.
Yeah, and standard water reactors just don't run hot enough for a lot of those industrial applications. But a high-temperature gas-cooled reactor does. So by coupling them, you get the electricity for the grid from the water reactor and the extreme heat for industrial steam from the gas-cooled reactor.
Wow, that is such a clever mechanical solution for heavy industry. And speaking of gas-cooled reactors, the update also mentions the HTRPM at the Shidawon site, which is already operating.
Yes, the pebble bed modular reactor. It's a completely different approach to nuclear physics.
It's wild. And then there's Jiapu, where they have the CFR 600 fast reactors.
Right, sodium-cooled fast reactors.
Which is another totally different piece of the puzzle.
Oh.
But I want to zero in on one specific detail from the notes that really caught my eye.
Oh, which one?
The Linglong one. The ACP-100 small modular reactor down at the Changjiang site.
Ah, yes, the SMR.
Yeah, because we've heard for years that SMR's small modular reactors are supposed to be the future. Just, build them small, build them in a factory, ship them out. But when you look at the statics of the Linglong one, well, where things are noted as unverified or TBD in our source data, we have to call that out, right?
We absolutely do. Whenever the source says something is unconfirmed or to be determined, we state that clearly.
Right. So you see them stamping out these massive, complex Hualong-1 reactors at this incredible pace. But the tiny modular SMR, it's still in this frontier PBD space.
Which is a really important reality check. Scaling up established technology is working brilliantly for them. Miniaturizing it, though making it modular, that introduces entirely new engineering friction.
Standardization is beating miniaturization.
It really is, at least for now. And it just reinforces why we have to stick to verifiable data and actual grid connections rather than, just projections.
Totally. So if we step back and look at the whole picture for the week of July 27, 2026, 125 gigawatts of capacity, 60 operating units, 36 under construction.
And a 15th five-year plan target of 110 gigawatts operating by 2030 that looks highly achievable.
It's just a completely redrawn map.
It is. And, I want to leave you, the listener, with a final thought on all this.
Go for it.
We talked about how they are building these reactors like an assembly line, standardized, relentless.
Yeah.
Well, think about what that means for the global economy. If a country can standardize the most complex energy infrastructure on Earth to the point where they are connecting reactors to the grid on a near monthly basis, what does that do to the future of heavy industry? If clean, baseline nuclear power can be stamped out the way we build commercial shipping vessels, how fundamentally does that rewrite the economics of global energy over the next decade?
That is a massive question. If energy becomes that abundant and that scalable, it changes everything.
It really does.
Well, that's something to mull over. Thank you for joining us on this deep dive. Keep questioning the data, keep looking at the facts, and we'll see you next time.